Glass is one of those materials that seems so ordinary that it rarely attracts much attention. It sits in windows, drinking glasses, phone screens, and countless everyday objects without anyone questioning why it behaves the way it does. Yet one of its most remarkable features is something that most people simply take for granted: the ability to let light pass almost effortlessly. Unlike wood, metal, or stone, glass allows a clear view of the world on the other side. It almost feels invisible, even though it is a solid object. Understanding why glass is transparent reveals an interesting story that blends physics, chemistry, and the behavior of light at the atomic level. Right here, on History of Simple Things. Transparency is not simply the absence of color. A transparent material allows visible light to travel through it with very little interruption. When sunlight strikes an object, several things can happen. The light can be reflected away, absorbed by the material, or transmitted through it. The balance between these three outcomes determines whether something appears transparent, translucent, or opaque. A brick wall absorbs and scatters nearly all visible light, preventing anyone from seeing through it. Frosted glass lets light pass but scatters it in many directions, making objects behind it appear blurry. Clear glass, however, allows most visible wavelengths to continue traveling in almost straight lines. This uninterrupted journey is what creates the familiar experience of looking through a window as though almost nothing is there. The reason glass behaves this way begins at the atomic scale. Most common glass is made primarily from silicon dioxide, the same compound found in sand. During manufacturing, sand is heated to extremely high temperatures until it melts into a liquid. As it cools, it solidifies without forming the neat crystal structure seen in minerals like quartz. Instead, its atoms freeze into a disordered arrangement known as an amorphous solid. Although the atoms appear randomly organized, they still interact with incoming light. Every atom contains electrons that can absorb energy under the right conditions. However, visible light simply does not carry enough energy to excite the electrons inside ordinary glass. Because those electrons remain undisturbed, the light continues moving through the material instead of being absorbed. In simple terms, the glass does not ignore the light. It just has no reason to stop it. Not every solid shares this unusual property. Metals, for example, contain electrons that are free to move throughout the material. When light strikes a metal surface, these mobile electrons begin vibrating almost instantly. Instead of allowing the light to pass through, they re-emit much of it outward, creating the shiny reflections associated with polished metal. Since the light cannot travel deeply into the material, metals appear opaque. Other materials absorb visible light because their electrons require exactly the amount of energy carried by those wavelengths. Pigments in paint, leaves, clothing, and skin selectively absorb certain colors while reflecting others. That selective absorption is what gives objects their appearance. Glass occupies a fortunate middle ground. Its electrons require far more energy than visible light can provide, so almost none of the visible spectrum is absorbed. As a result, light passes through with very little loss. Despite being transparent, glass is not completely invisible. Looking at a window during the day can reveal reflections of the surrounding environment. This happens because when light moves from one material into another, such as air into glass, a small portion of it bounces off the surface. Most of the light continues through the glass, while roughly 4% reflects from each side of a typical pane. This is why windows can sometimes act like mirrors, especially when one side is much brighter than the other. The remaining light passes through the glass, bends slightly as its speed changes, and eventually exits the other side. Although ordinary window glass appears clear, different types of glass can behave differently. Tiny impurities can change how much light passes through or even give the glass a slight color. Iron impurities, for example, can create a faint green tint that becomes especially noticeable along the edges of thick glass. Manufacturers can also add specific ingredients to produce colored glass. Stained glass uses carefully selected materials that absorb certain wavelengths while allowing others through. Modern glass can even be treated with anti-reflective coatings, which reduce reflections and allow more light to pass through lenses, screens, and other optical devices. Glass stays transparent when its internal structure allows light to travel through smoothly. Scratches, cracks, and tiny air bubbles can disrupt that path by scattering light in different directions. Instead of continuing straight through, the light spreads out, making the damaged area appear cloudy or white. The same idea explains why crushed glass looks much less transparent than a solid pane. Each piece may still be transparent, but its many rough surfaces scatter light in countless directions. Snow works similarly. Ice itself can be transparent, but millions of tiny ice crystals and air pockets scatter light, making snow appear white. Glass is transparent because of the way its atoms interact with visible light. Its electrons cannot easily absorb the energy carried by visible wavelengths, allowing most light to pass through. Its smooth structure also prevents much of that light from scattering, which is why objects on the other side remain clear. A small amount of light is reflected, but most continues through the material. What appears to be an ordinary pane of glass is actually the result of fascinating physics happening at the atomic level. Its unique structure allows light to travel through a solid material with remarkably little interference. That combination of chemistry and physics is what makes glass both solid and, in a sense, almost invisible. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.